The 6th generation 2026 Toyota RAV4 does not just iterate. It renders the current compact SUV segment statistically obsolete, while market competitors continue to rely on high-stress, small-displacement turbocharged architectures to meet emissions standards. Toyota has instead executed a comprehensive overhaul of the foundational engineering principles defining the compact crossover. This vehicle represents the absolute apex of the Toyota New Global Architecture K platform and the 5th generation hybrid system, creating a machine where mechanical longevity and thermal efficiency are not merely targets but mathematical certainties. We are not looking at a simple facelift. We are looking at a complete re-engineering of the internal combustion and electric drive integration that will serve as the segment benchmark for the next decade. To understand the superiority of the 2026 model, one must first dissect the chassis. The updated TNGA-K platform serving as the skeleton of this vehicle has undergone a radical stiffening protocol through the expanded application of laser screw welding and the strategic use of high-damping structural adhesives across key unibody joinery, specifically at the rocker panels, well apertures, and the rear floor cross members. Torsional rigidity has been increased significantly over the outgoing 5th generation model. This is not about perceived quality. It is about suspension kinetics. A stiffer chassis allows the suspension geometry to perform its damping duties without fighting chassis flex. The engineering team has utilized hot-stamped, ultra-high tensile strength steel in the A and B pillars, which not only improves occupant safety ratings but lowers the center of gravity. The result is a platform that resists lateral deformation under cornering loads, providing a neutral, planted handling characteristic that defies the vehicle's ride height. The heart of this engineering marvel is the 5th generation Toyota hybrid system, or THS5. This is the most efficient and thermally managed powertrain Toyota has ever mass-produced. It abandons the constraints of conventional geared transmissions and belt-driven accessories entirely. The system pairs the internal combustion engine with two electric motor generators, MG1 and MG2, housed within a re-engineered transaxle. The primary drive unit is the A-5A FXS 2.5-liter dynamic force 4-cylinder engine. This is not a carryover unit. It is a masterpiece of thermodynamic engineering, utilizing a massive 14.0-to-1 compression ratio. In a conventional engine, such high compression would result in catastrophic knock or pre-ignition. However, the dynamic force engine mitigates this through the Atkinson cycle, where the intake valves remain open slightly longer during the compression stroke, effectively making the expansion ratio larger than the compression ratio. This extracts every joule of energy from the combustion event. Furthermore, the cylinder head design features laser-clad valve seats and a revised intake port geometry that induces a high-tumble airflow. This tumble ensures a rapid, uniform combustion flame front, which is critical for the exhaust gas recirculation protocols used to lower combustion temperatures and nitrogen oxide emissions. Fuel delivery is handled by the D4S dual injection system, which employs both low-pressure port injectors and high-pressure direct injectors. Under low loads, port injection is used to clean the valves and ensure stable combustion. Under high loads, the system switches to direct injection to cool the intake charge and maximize power. This dynamic switching allows the A-5A FXS to achieve a thermal efficiency of 41%. A figure that rivals complex diesel engines and stands as a testament to the obsolescence of the simplified turbocharged engines found in competitor vehicles. Torque from this engine is managed not by a gearbox, but by the P-Series ECVT transaxle. It is imperative to correct a common misconception here. This is not a belt and pulley CVT found in lesser vehicles, which rely on friction and are prone to slippage and wear. The RAV4's ECVT utilizes a planetary gear set power split device. The engine drives the planet carrier, the MG1 generator is connected to the sun gear, and the MG traction motor is connected to the ring gear, which drives the wheels. This arrangement allows for an infinite number of gear ratios solely by varying the rotational speed of the Sun gear via NG1. There are no clutches to burn out, no torque converter to generate heat, and no belts to snap. It is a solid-state mechanical coupling that is virtually indestructible. In the 2026 model, this transaxle uses a new, low-viscosity lubrication system and optimized gear tooth geometry to reduce parasitic loss by approximately 20% compared to the previous generation. The electrical architecture supporting this system has also been overhauled. The power control unit, or PCU, which governs the flow of high-voltage electricity between the battery, motors, and generator, has been miniaturized and boasts a 14% reduction in energy loss. This feeds into a new lithium-ion battery pack, which replaces the older nickel-metal hydride chemistry found in lower trims of the previous generation. This new battery is lighter, more energy-dense, and sits physically lower in the chassis, further aiding the center of gravity. The battery management system is more aggressive, allowing for greater electric-only driving speeds and a more substantial contribution from the electric motors during acceleration, thereby reducing the load on the internal combustion engine. Suspension kinematics have been tuned to complement the rigid TNGAK platform. The front utilizes a McPherson strut design with revised damper valving that focuses on low-speed bump compliance while maintaining high-speed stability. The geometry includes a specifically calculated kingpin inclination to provide self-centering steering torque, enhancing straight-line tracking on highways. At the rear, a multi-link double wishbone setup separates longitudinal and lateral force management. This decoupling is crucial. It allows the wheel to move backwards slightly to absorb road impacts, improving ride comfort, while remaining stiff laterally to prevent toe change during cornering, improving stability. The anti-squat geometry has been enhanced to keep the vehicle level during the immediate torque delivery characteristic of the electric motors aerodynamically. The 2026 RAV4 is a study in drag reduction. The drag coefficient has been lowered through the use of active grille shutters, which close when cooling demands are low, forcing air around the body rather than into the turbulent engine bay. The underbody is clad in extensive paneling that smooths the airflow beneath the car, creating a Venturi effect that reduces lift at high speeds. Even the taillights feature small aero-stabilizing fins or vortex generators that manage the separation of airflow at the rear of the vehicle, reducing the low-pressure wake that acts as a drag anchor. We must conclude with a scientific verdict on reliability. The contemporary automotive market is flooded with downsized 1.5-liter or 2.0-liter turbocharged engines pushed to upwards of 20 psi of boost to generate acceptable power. These engines place immense thermal and mechanical stress on pistons, connecting rods, and turbo bearings. They are inherently designed with a finite fatigue life. The 2026 RAV4's naturally aspirated to 0.5-liter engine, assisted by electric motors, never experiences these high-stress load spikes. The electric motors handle the initial torque demand, the most stressful phase for a gas engine, allowing the internal combustion component to operate largely in its steady-state sweet spot. The planetary ECVT has no friction components to wear out. The braking system, utilizing regenerative braking, reduces wear on friction pads and rotors by over 50%. When you analyze the fatigue cycles of the aluminum alloy block, the thermal management of the hybrid inverter, and the simplicity of the power split device, the projection is clear. While competitors will face turbo failures, carbon buildup issues, and transmission replacements at the 150,000-mile mark, the 2026 Toyota RAV4 is engineered to remain mechanically viable well past 300,000 miles. It is not just a car. It is a masterclass in high-efficiency durability. Would you like me to create a comparison table contrasting these 2026 RAV4 hybrid specs against the 2026 Honda CR-V Hybrid and Hyundai Tucson Hybrid?